Our feelings are an incredible thing. We have amazing acuity and breadth of perception. With your ears, you can hear the roar of a supersonic plane and the peaceful, quiet sound of drops of water falling from a faulty tap in the shower and driving you crazy when you try to get in. The sense of touch allows you to feel the handles of a 10-kilogram bag cutting into your fingers, and at the same time, the touch of the legs of a hungry mosquito weighing 2 milligrams crawling along your leg. Or vision. If the earth were flat, then, on the darkest night on a smooth plain, you would be able to see the flicker of a lit match from a distance of 48 km. Think about this for at least 10 seconds. These are some kind of miracles. Back in 1941, vision specialist Selig Hecht and his colleagues at Columbia University made what is still considered a reliable measurement of the absolute threshold of vision. They have figured out the minimum required number of photons that must hit our retina to trigger visual awareness. The experiments examined the threshold under ideal conditions. The eyes of the study participants were given time to adapt in complete darkness. The flash of light acting as a stimulus had a blue-green wavelength of 510 nanometers, which our eyes are most sensitive to. This color was directed to the periphery of the retina, which is rich in light-sensitive rods. Have you ever noticed that in your peripheral vision, you are able to see those dim stars in the sky that immediately disappear under direct gaze? In general, scientists have found that between 5 and 14 photons are absorbed, which is almost nothing. That is, when 5 to 14 rod cells out of about 100 million are activated, your brain is told that you are seeing something. Vision truly occupies a special place among all our senses. Through vision, we process most of the sensory information we receive. According to existing estimates, the human visual system processes information at a speed of 10 million pieces of information per second. If we did not have vision, astronomy as a science would most likely never have arisen. But there is a question that I constantly raise in my videos. Do you know what is hidden beyond our senses? Do we perceive reality as it really is? The answer is no. Moreover, we are infinite, and this is not a myth. We are infinitely far from this. As the founder of quantum physics, Max Planck, said, "Modern physics makes a special impression on us precisely because of the old truth, according to which there is a reality that we are not able to perceive with our senses, and there are tasks and conflicts in which this reality plays, for we have a much more important role than all the treasures of the sensory world." Epistemology deals with the boundaries and possibilities of human knowledge. Simply put, epistemology views the process of cognition as the relationship of who knows to what is known. Remember Plato's allegory about the cave? Prisoners all their lives, unable to even move, see a picture of shadows cast by real objects of the objective world. Unhappy people spend their entire lives seeing the world as small, flat, and black and white. But the most terrible thing is that they cannot even imagine that the real world is not really like that. In fact, it is infinitely different from the play of shadows on the cave wall. Are we not too similar to those same prisoners, even if we leave aside philosophy from a purely physical point of view? Are there infinities that are hidden from us? The answer is yes. Now you will learn something about some of them. We will take light as something real, as a physical phenomenon that our vision is designed to perceive, and compare it with what we ultimately receive in sensations, with that projection of reality in our head. This video is a kind of adaptation of the idea of the American physicist and theorist and Nobel laureate Frank Wilczek, or rather the idea from essentially just one chapter of his book, The Beauty of Physics. His entire book is a long meditation designed to answer the question, the main question. He writes exactly like that at the very beginning. Just listen. Does our world embody beautiful ideas? That is, can our world be considered a work of art? It is quite surprising to hear such formulations from the greatest physicist of our time. The chapter that I will now talk about under the title Doors of Perception contains answers to all sorts of strange and non-obvious questions like, are there infinities under our noses that we do not see? What is color really? How do some women see in 4 dimensions rather than 3? And much more. Yes, this is not the only chapter that I would like to tell, and perhaps I will film something else if I decide that I can properly convey the beauty of the ideas presented. Throughout the book, you are captivated by the author's ability to bring out, bit by bit, from different pieces, something holistic, meaningful, and truly magnificent. Frank Wilczek believes that real modern physics. In fact, the entire modern information civilization began with a man whom almost no one in the street now knows. A man without whose discovery you would not be able to watch this video at the moment. And Einstein kept his photograph on the wall of his office. And when he was once asked, did he stand on Newton's shoulders? He replied, no, I stood on Maxwell's shoulders. We are talking about the British theoretical physicist James Clerk Maxwell, and he really loved all these problems of our perception. In the 4th century BC, when philosophy and science developed together in Greece, Pythagoras formulated his theory of light, according to which rectilinear visible rays are suddenly emitted by the eye and feel the object, giving a visual sensation. In his famous natural science dialogue, Timaeus, Plato already wrote, "From the organs of the gods, first of all, they created luminous eyes. And the gods made it so that the fire, akin to daylight, which is inside us, flows purified through the eyes." And to the question, why didn't we see anything in the dark then? There were all sorts of clever answers. Today we know that the eyes themselves do not emit any rays, but only process the visible light entering them. Just in case, let me remind you that light is not only what comes from a light bulb, the sun, or the stars. Light is generally all that you see. You do not see the mug as such, but the photons of light that were reflected from its surface and hit the retina of your eyes. Yes, this is not a particularly original statement, but we really rarely think about it. But that's not all. There's something else. Before Maxwell, probably no one thought about it at all. In 1864, he published the article, Dynamic Theory of the Electromagnetic Field. In it, for the first time, you can find the equation that appears in all of today's main theories. These Maxwell equations changed everything. Now we know that there are a bunch of different fields around us that we don't see or don't feel at all. But before Maxwell, the concept of a field as a form of matter did not exist. It was Maxwell who filled space with streams of energy that, damn it, control the world. In addition, these same equations gave us a completely new understanding of what light is, and that most of what we perceive is only a tiny part of what actually exists. The equations showed that there was more to light and predicted the existence of light that we cannot see. If the gates of knowledge were open to people, infinity would open. But people have hidden themselves from the world and see it only through the narrow crevices of their caves. William Blake, The Marriage of Heaven and Hell. Indeed, we experience only a tiny fraction of what light has to offer, because in reality, the world of physical light is... Are you ready? This is a doubly infinite dimensional space, from which we perceive only its three-dimensional projection. Don't be alarmed, you will soon understand what is meant here. Take a look at the photo of young Maxwell. Yes, what we are now interested in is not his strange look, by which people usually decide that you are strange, but the entertaining toy in his hand is a colored top. Yes, the photo itself is, of course, black and white. Color photography had not yet been invented. Maxwell himself would create it a little later. So Maxwell developed this same colored top specifically to study color perception. A simple yet profound idea that turns a colored spinning top, similar to a child's toy, into a powerful tool for studying color perception. What's the point? I'll talk about the two types of yellow that you can get, as it were, true spectral yellow, by passing sunlight through a prism. However, you can also simply mix spectral red and spectral green to get a non-spectral yellow, which as a physical entity will be very different from spectral yellow. However, we perceive both of these colors as identical. Likewise, you don't need to add every color in the sunlight spectrum to get white that looks like sunlight. You can simply mix red, green, blue, and get a white color that is absolutely indistinguishable from sunlight. Again, as a physical entity, this ray is significantly different from sunlight. But human vision perceives both equally. It's so counterintuitive. Use blue, red, green to suddenly get the purest white. You will never be able to do anything like this with paints, because when you paint, you choose which spectral colors your drawing should absorb and which not. By mixing a sufficient amount of different pigments, that is, by mixing the absorption abilities of different paints, you will thereby create a pattern that absorbs everything, the entire visible spectrum, and get no reflection. That is black color. Beam stacking is in principle simpler and physically more fundamental than pigment mixing. In general, combinations of spectral colors can look the same, and it is important for us to understand which combinations look the same, what kind of space to which the perceived colors belong. It was to find out all this that Maxwell came up with his colored tops. Try to forget for a moment that you are a 21st century person and admire how they work. For most of human history, people believed that vision gave us a snapshot of reality, an instantaneous state of the world around us, and a continuous reflection of events occurring over time. However, vision is little more than a series of snapshots, each taken with a shutter speed of 1/25 of a second. That is, conventionally, we get our not very impressive 25 frames per second. But then magic happens. Our brain fills in the gaps between these snapshots to create the illusion of continuity. Therefore, sometimes when you look at the second hand of a watch, it may seem to you that the hand has frozen for a longer time than usual. Actually, the most famous application of this feature of our vision is cinema. The colored top also works on the same principle, using inertial vision. When we look at a top, our eyes eat up the reflected rays. Maxwell's colored spinning tops allow us to know in a very systematic and quantitative way which combinations of colors look the same. The main result obtained from these studies is that by using just 3 colors, we can get a match with any other color. So, for example, we can use special red, green, and blue in the right proportion to get orange, chartreuse, reddish-brown, sky blue, dark peony, or any other desired color. In fact, this is exactly what is happening now, because the screen from which you are watching the video does not reproduce any colors except blue, red, and green. Yes, when you are promised a million colors on a screen, that refers to the millions of different ways to combine the relative intensities of those sources. In other words, we can designate any perceived color by saying how much red, green, and blue is taken to produce it. This is completely similar to how we can identify a place by saying how far it is from us in the north, south, east, west in vertical directions. Ordinary space is a 3-dimensional continuum, and the same 3-dimensional continuum is the space of perceived colors. Look at the picture. This is Claude Monet's haystack. It can be considered as another type of colored top, which uses the inertia of vision not in time, but in space. Yes, for artists, the ability to achieve the same perceived color in many different ways opens up creative possibilities. You can add local texture while maintaining an overall average color. Spatial averaging is less coarse than temporal averaging, and therefore provides a wider range of options. By adding different pigments separately on different, although very close parts of the canvas, rather than overlapping each other. The Impressionists followed a strategy similar to that used in Maxwell's colored tops, but transferred from time to space. In both cases, light from different places is combined according to the rules of ray addition, because the artist does not mix paints, but the light they reflect. Light. What is the light that we see? What is he? The light we see is a special case of an electromagnetic wave with a wavelength in a fairly narrow range, from about 370 to 740 nanometers. What you are about to learn is amazing and truly beautiful, because the electromagnetic wave itself looks like this. The electric field is at right angles to the magnetic field, as you can see, and they are both at right angles to the direction of motion. This is an ideal 3-dimensional design, and this is exactly the same geometry that Maxwell described in words. But that's not all. Changes in electric fields cause changes in magnetic fields in such a way as to create electric fields, which create magnetic fields, and the whole process takes on a life of its own. The first, as it were, gives rise to the second, so that the second gives birth to the first, and so on ad infinitum. It was Maxwell who combined electricity and magnetism and called them the fundamental force. Having discovered the possibility of the existence of electromagnetic waves and calculating their speed, James Maxwell discovered that it coincides with the speed of light. For the scientists, this became evidence that light actually consists of these same electromagnetic waves, which have a fascinating geometry and nature of existence. So if you happen to see something ugly, you can always remember what the picture you are watching consists of. To this day, this remains our fundamental description of light. Visible light corresponds only to a small band of the electromagnetic spectrum, which includes electromagnetic waves of all possible wavelengths. Now we know that not only light, but also radio waves, microwaves, infrared, ultraviolet radiation, gamma rays, they are all electromagnetic waves, only with different wavelengths and purities. And it was Maxwell who predicted this. Thus, if you think that almost all the benefits of modern civilization are good, then you should thank James Clerk Maxwell for them, first of all. Returning to electromagnetic waves, as you understand, a monstrous part of them simply completely eludes our vision. We need different sensors, instruments, and sensors to record the homeless, raging ocean in which we find ourselves and which we are unable to perceive. For example, we do not see radio waves, and without radio receivers, we would never know about their existence. Even if we talk exclusively about visible light, which we have learned to perceive in the process of evolution, because our atmosphere transmits these long waves best, then our perception does not give us the opportunity to fully use even this meager resource. Ask yourself the question, what parts does the signal entering your eyes consist of? There are two parts. The first is the spatial signal. It contains information about the direction of light rays coming from various objects. So we form, as it were, the outlines of the image. The second part is the color aspect, and this is where the fun begins. This signal contains information of a different kind. We can perceive black and white images, or we can have color images. In extreme cases, these are just solid colors covering the eyes that do not create images. And if we understand in general terms what light is, then what is color? Frank Wilczek writes that this is a very deep and complex and beautiful question, and everything that was voiced before was just preparation for answering it. In short, while the image itself contains information about what is happening in space, color tells us what is happening in time. For example, when we perceive pure spectral yellow, our eyes tell us that the incoming electromagnetic waves are pure waves that repeat themselves approximately 520 trillion times per second. When we perceive special red, and the message says that the repetition occurs 450 trillion times per second, and that sounds pretty darn cool, if not for one, but you know, what is the very problem of the lost infinities that we do not see? Precisely in the fact that our eyes do not distinguish the difference between spectral yellow and yellow, consisting of a mixture of red and green. They do not see the difference between spectral red and the large number of combinations of other colors that appear red. That is, a huge variety of input data is combed under one brush, or rather under three. Wilczek writes, a true analysis of the input signal in terms of color should extract the same information as Newtonian analysis of light using a prism. In other words, such an analysis would separate the input signal into pure spectral components, each of which has its own independent intensity. To represent the result of such an analysis, we would need to specify a continuous infinite sequence of numbers, one for the contribution of each pure spectral component. This space of potential information that light carries is not only infinite, it has an infinite number of dimensions, but the projection of this information, which our eyes perceive, contains, as Maxwell discovered, only 3 numbers. It sounds complicated, and I read it 10 times just to understand something. In short, the space of color information is infinite dimensional, but we perceive as color only a 3-dimensional surface onto which these infinite dimensions are projected. That is, we have a whole infinity escaping our sight. Frank Wilczek says that in fact it is even worse. This is, strictly speaking, a double infinity. Why? The answer is simple. Polarization. Look again at the electromagnetic wave. Electric fields oscillate in the vertical direction and magnetic fields in the horizontal direction. But there is also a second, exactly opposite option in which the electric fields will be horizontal and the magnetic fields will be vertical. This rotated solution oscillates at the same rate as the original, so it represents the same spectral color, but physically it is completely different. This is called wave polarization. What is polarization? You can easily see the example of polarized glasses, which transmit light or electromagnetic waves in only one plane, thereby reducing eye strain and protecting them from glare. Therefore, the electromagnetic information entering our eye at every point in the image has an infinite number of dimensions twice. Because for each spectral color, there are two possible polarizations, each of which can be stronger or weaker independently of the other. Human vision does not notice this because the human eye does not see the difference between different polarizations of light. As we understand, he sees little at all. It will sound more beautiful like this. Our perception of color projects the twice infinite dimensional space of physical color onto the three-dimensional wall of our inner cave. Can we escape from this cave in order to open up new dimensions? But someone can tell what the biological reasons are for this peculiarity of our vision. The thing is that information about color is extracted by three types of protein molecules: rhodopsins. When light hits one of these molecules, there is a certain probability that the molecule will absorb a unit of light, a photon, and change shape. The change in shape causes a small pulse of electricity, which is information that our brains in turn use to construct our senses of vision. Further, the probability that a single unit of light will be absorbed depends on its spectral color and on the properties of the receptor molecule. One type of receptor more readily absorbs light from the red part of the spectrum. Another reaches its peak in green, and a third in blue, although their tuning is not narrow. Thus, physics, and in particular Maxwell, helped biologists understand what to look for in order to study the most complex and important organs for vision. You just need to count the number of receptors and replace their absorption abilities. Why does a bullfighter need a red rag? Of course, for the audience, because bulls perceive only shades of gray. Dogs with this are better able to see the two-dimensional space of colors. People suffering from color blindness or colorblindness are also able to see only a two-dimensional space of perceived colors. They lack one of the types of protein receptors or have mutated proteins that do not distinguish colors well. For example, director Christopher Nolan is colorblind and cannot distinguish between shades of green and red. Color blindness affects women less often, but it is quite common among men. About every 12th man in Northern Europe has it. But here you might think, wait, does it circle the opposite cases? Yes, there are special people, tetrachromats. They have not 3, but 4 types of color receptors. About 12% of women have this feature, but most of them have type 4 color receptors that are no different from one of the existing ones, and their color perception is identical to that of most people. Only in the case of a very rare additional mutation does the sensitivity of the quarter type of receptors differ from the other 3 curves, and such people are able to see additional shades. Tetrachromats can distinguish combinations of spectral colors that most people perceive as indistinguishable. Thus, they perceive color not in 3, but in 4 dimensions. But generally speaking, in general, mammals have rather mediocre color vision. Many species of insects and birds have 4 or even 5 color receptors, including those sensitive to ultraviolet radiation and even to polarization. Many flowers are patterned and brightly colored in the ultraviolet spectrum to attract their pollinators. Within the sensory universe of color, these beings reveal dimensions that elude us. However, the absolute champions with supervision are stomatopods or mantis crabs. Depending on the species, they can see between 12 and 16 color dimensions. Just think about the range of their sensitivity reaching to deciphering some information about polarization and, damn it, to the perception of infrared and ultraviolet rays. The question of what it is like to see, as mantis crayfish see, again sends us into the realm of philosophy, in this case in the field of philosophy of mind, and to the most famous question in modern consciousness science: what does it mean to be a bat? As you remember, we already discussed this homeless topic in the video Consciousness, because you can see, for example, photographs of the sun in X-ray, infrared, ultraviolet, and other invisible ranges using appropriate technology. But in fact, they don't seem to have any color. Literally, for such photographs, special filters are used that cut off all ranges except the necessary ones, and we simply tint the final result in one way or another in familiar colors. So the question, for example, of what it is like to see in the infrared range is far beyond our understanding. Why did stomatopods develop their exceptional talent for color perception? This is a big question of deep interest. One acceptable answer is that they use it to exchange secret messages with other mantis crabs. Wilczek believes that they use their own bodies to create impressive color images that are almost inaccessible to us and demonstrate their forms to potential partners. It's like a peacock's tail, but the embodiment is much more powerful. In support of this idea, we can note that some species of stomatopods are very brightly colored, so you see even to us, and it is those species that have the most advanced color vision that are especially richly colored. Amazing creatures. The great mystery is how such a small crustacean brain copes with such an abundance of sensory information. James Clerk Maxwell's theory of electromagnetic fields was considered interesting but unconvincing in his time. The most important prediction of Maxwell's theory is that electric and magnetic fields can give life to each other and propagate as self-renewing waves. It was not confirmed at that time. This will be done a little later by Heinrich Hertz in his experiments. As a young man, Maxwell wrote an entry in his personal diary that foresaw the life he was to live. Happy is the person who, in the work of today, sees a logical part of the work of his whole life in the embodiment of the work of eternity. The grounds for his confidence do not change, so he shares infinity. He works hard at his daily affairs because the present has been given to him as his own. So, man must be the embodiment of the divine processes in nature and carry forward the union of the infinite with the finite, without neglecting the temporality of his existence. Remember that only a separate action is possible in it, and without ignoring the eternal from your point of view, knowing that time is a mystery of contemplation that a person cannot endure, until the eternal truth illuminates it. He wrote these extremely meaningful lines at the age of 23. At 25, he will become a professor at Aberdeen College. At 29, one of the best physicists in Great Britain. At 48, he will die untimely. If you ever find yourself in Edinburgh, then do not deny yourself the pleasure of touching the great. There is a monument to Maxwell, who pierces infinity with his gaze and holds a colored top in his hands. Thanks to him for making this video possible. Thank you for watching. Thank you to those who support me.